Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on density. So we're going to look at the video solutions to the practice questions. If you need any extra help on density, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video number 384, there's a dedicated video to show you there on density. But as I said, in this video, we're going to focus on the video solutions to the practice questions. So let's get started. Okay, so let's have a look at question number 1. So question number 1 says a piece of wood has a mass of 8 grams and a volume of 10 centimeters cubed. And the question says work out the density of the wood. So remember that density is equal to mass divided by volume. So if we want to find the density of the wood, we're going to do its mass divided by its volume. So in terms of this question, the density will be equal to its mass, which is 8, divided by its volume, which is 10. And 8 divided by 10 is equal to 0.8. So the density would be equal to 0.8. And then in terms of our units, we've done the mass, which is in grams, divided by the volume, which is in centimeters cubed. So it'd be grams per centimeter cubed. And that's it. So the density of the wood is 0.8 grams per centimeter cubed. And that means that every single centimeter cubed of this wood has got a mass of 0.8 grams. So our answer is 0.8 grams per centimeter cubed. Okay, let's look at our next question, question number 2. Okay, so our next question, question number 2. Question number 2 says, what is the volume of a piece of metal that has got a mass of 300 grams and a density of 6 grams per centimeter cubed? So in this question, we want to find the volume of this piece of metal. Now, in terms of doing that, we can look at the question, look at the units and see, well, the density, saying it's 6 grams for every centimeter cubed, and the mass of the metal is 300 grams. So if we divide 300 by 6, that'll tell us how many centimeters cubed there would be. So if we do 300 divided by 6, that's equal to 50. So that must mean the volume of the piece of metal is 50 centimeters cubed. Alternatively, you could rearrange the formula, and if you rearrange the formula, you'll get the volume is equal to its mass divided by its density. So here, the volume will be equal to the mass, which is 300, divided by the density, which is 6, and 300 divided by 6 is equal to 50. So that means the volume of this piece of metal is 50 centimeters cubed, and that's it. So the answer is 50 centimeters cubed. Okay, let's look at our next question, question number 3. Okay, let's look at our next question, question number 3. So question number 3 says a piece of plastic has got a density of 1.3 grams per centimeter cubed and a volume of 100 centimeter cubed. And the question wants us to work out the mass of the piece of plastic. So we want to find the mass of this piece of plastic. So here we know that every single centimeter cubed has got a mass of 1.3 grams. And there's 100 of them. So if we do 1.3 times 100, that'll be 130. So that means the mass of this piece of plastic is 130 grams. Alternatively, we could rearrange the formula. And remember here, we've got density is equal to mass divided by volume. So density is equal to mass divided by volume. Multiplying both sides by the volume would give us that the density multiplied by the volume is equal to the mass. So that means that the mass is equal to density times volume. So here, the mass would be equal to the density, which is 1.3, because it's 1.3 grams per centimeter cubed, multiplied by the volume, which is 100, and 1.3 times 100 is 130. So that means the mass of this piece of plastic is 130 grams. So 130 grams, and that's it. Okay, let's look at our next question, question number 4. Okay, so question number 4 says that iron has got a density of 7.8 grams per centimeter cubed. So every single centimeter cubed of iron has got a mass of 7.8 grams. And a solid iron statue has got a mass of 877.5 grams. And the question is to work out the volume of the statue. Now this is a calculator question, so that's quite handy. We don't need to do any multiplications or divisions without a calculator. So we want to find the volume. So the volume, well, if we think about it, the whole mass is 877.5 grams, and each centimeter cubed has got a mass of 7.8 grams. So if we divide the total mass by the density, that'll give us the volume. So the volume will be equal to the mass divided by density. So in terms of the mass of the whole statue, that's 877.5. So 877.5 grams divided by the density, which is 7.8. And if we do that division, it'll tell us how many centimeter cubes there would be. So in other words, the volume of the statue. So let's do that. And it's a calculator question, so we just need to type that into our calculator. And when we do that, we get an answer of 112.5 centimeters cubed. So the volume of the statue is 112.5 centimeters cubed, and that's it. Okay, let's look at our next question, question number 5. Okay, so question number 5 says a solid silver spoon has got a mass of 65.1 grams. The volume of the spoon is 6.2 centimeters cubed, and the question says find the density of the silver. So here, if we think about it, we've got the total mass of the spoon, we've got the volume of the spoon, and if we divide the mass by the volume, we can find the mass of each centimeter cubed, or the density. So the density is equal to the mass divided by volume. the mass would be 65.1, the volume is 6.2. So if we do the mass divided by the volume, we're going to get the density. And remember, the density is the mass of each one of the centimeter cubes of the material. So if we do 65.1 divided by 6.2, that's equal to 10.5. So that means that the density of the silver is 10.5 grams per centimeter cubed. So every single centimeter cubed of this silver has a mass of 10.5 grams. And you can check your answer. If you times that by 6.2, that should give you the mass of the whole spoon, which would be 65.1. Okay, let's look at our next question, question number 6. Okay, so question number 6. So question number 6 is a bit different than questions 1, 2, 3, 4, and 5, because it says that a glass cube of side length 5 centimeters has got a mass of 306.25 grams. And we've been asked to calculate the density of the glass. Now we can see, remember that density is equal to mass divided by volume. Now we've got the mass of the cube, which is 306.25, but we need to divide that by the volume. But here we've not been told the volume of the glass cube. But we know it's a cube, so we know that to find the volume of a cube, we do the length times the width times the height. And because the length of each side is 5 centimeters cubed, the volume of this cube would be 5 times 5 times 5. Because it's a cube, so each of the lengths are the same length, so it would be 5 times 5 times 5. And 5 times 5 times 5 is equal to 125 centimeters cubed. So we've got the volume of the whole cube, it's 125 centimeters cubed. And we've got the mass of the whole cube, 306.25. So if we take the mass and divide it by the volume, that'll give us the density. So let's do that. So 306.25 divided by 125 is equal to 2.45. So 2.45. So that means that each centimeter cubed of this glass has got a mass of 2.45 grams. So the density is 2.45 grams per centimeter cubed. So 2.45. Okay, so let's have a look at our next question, question number 7. So question number 7 says a liquid has got a mass of 10 kilograms and a density of 1.18 grams per centimeter cubed. So each centimeter cubed of this liquid has got a mass of 1.18 grams. And the question says calculate the volume of the liquid and to include suitable units. So what I'm going to do in this question is, well, first thing I notice is that we've got here kilograms, and in terms of the density, it's grams per centimeter cubed. So I'm going to change the mass into grams. So each kilogram, kilo, is 1,000 grams. So 1 kilogram, is equal to 1,000 grams. So that means that 10 kilograms would be 10,000 grams. So 10,000 grams. So that means the mass of the liquid is 10,000 grams. And the density is 1.18 grams per centimeter cubed. So if we divide 10,000 by 1.18, we can see how many centimeter cubes there'd be. So how many centimeters cubed of liquid there'd be. In other words, the volume of the liquid. So the volume will be equal to the mass divided by the density. So if we take the mass, which is 10,000, so 10,000, and we divide that by the density, which is 1.18, that'll give us the volume, how many centimeters cubed of liquid there is. So it's a calculator question, which is quite nice. So let's get our calculator. 10,000 divided by 1.18 is equal to 8,474.576 and so on centimeters cubed. And the question didn't ask us to give it to so many decimal places, so I'm just going to round this to 3 decimal places. So it'll be 8,474.576 centimeters cubed. So that's it, we've found the volume of the liquid. So in this question, what we done was we changed the 10 kilograms into grams, and then we just approached it like the other questions that we've looked at so far. Okay, let's look at our next question, question number 8. Okay, let's look at our next question, question number 8. So question number 8 says a garden ornament has a volume of 0.05 meters cubed. And the ornament is made from stone that has got a density of 6.4 grams per centimeter cubed. And we've been asked to calculate the mass of the ornament and to include suitable units. So in this question, the thing that I notice here is the volume is in meters cubed, but the density is in grams per centimeter cubed. So I'm going to change the volume into centimeters cubed. Now, don't make the mistake of thinking there's 100 centimeters cubed in a meter cubed. That's not the case, okay? Because if you think about it, if we've got a cube and we have that it's a 1 meter cube, so 1 meter by 1 meter by 1 meter, that would be, a volume would be 1 meter cubed, because 1 meter times 1 meter times 1 meter would be 1 meter cubed. But if we change that cube, if we had the same cube, and instead of using 1 meter times 1 meter times 1 meter, and we've done 100 centimeters times 100 centimeters times 100 centimeters, that would be 1 million, 1, 2, 3, 4, 5, 6 zeros, centimeters cubed. So 1 meter cubed is 1 million centimeters cubed. So make sure that you're not multiplying by 100 here. We're actually going to multiply by a million, because the change from meters cubed cubed to centimetres cubed, you multiply by a million. So let's take the 0.05 and multiply that by a million. 1, 2, 3, 4, 5, 6. And when we do that, we get that's equal to 50,000 centimetres cubed. So that means the volume of this ornament is 50,000 centimetres cubed. Now, what's great is we want to find the mass of the ornament. Well, we know that it's got a density of 6.4 grams per centimetre cubed. So each centimetre cubed has got a mass of 6.4 grams. And there's 50,000 of them. So if we do 6.4 times 50,000, we can find the mass of the ornament. Or we could rearrange the formula that mass is equal to the density times the volume. So the density is 6.4. The volume is 50,000. So if we times the density by the volume, we get the mass of the object. So 50,000 times 6.4 is equal to 320,000. So 320,000 grams. Now, since it includes suitable units, I think here it would be quite useful to convert this into kilograms. So I'm going to divide this by 1,000. So dividing this by 1,000, we'll take off 3 zeros, 1, 2, 3, so we'll be left with 320. So the mass of the ornament is 320 kilograms. And that's it. Okay, so let's have a look at question number 9. So question number 9 says, the mass of 3 meters cubed of tin is 21,840 kilograms. And part A says, work out the density of tin. So we want to find the density of tin, and if we have a look at the units here, we've got it kilograms per meter cubed, so we want to find how many kilograms each meter cubed weighs. So because we've got 3 meters cubed, if we divide by 3, we can find the mass of 1 meter cubed. So in other words, we want to divide the mass by the volume. So density is equal to mass divided by volume. So the mass is 21,840 and the volume is 3. And if we do 21,840 divided by 3, that'll be the density. Now this is a non-calculator question, so I'm going to use the bus shelter method here. 21,840 divided by 3. So how many 3's go into 2? 0, remainder 2. How many 3's go into 21? That's 7. How many 3's go into 8? That's going to be 2, remainder 2. How many 3's go into 24? That's 8. And how many 3's go into 0? That's 0. So that means that's equal to 7,280. And then obviously in terms of our units, it's kilograms per meter cubed. So kilograms per meter cubed. So the density of tin is 7,280 kilograms per meter cubed. And then the question carries on. It says the density of aluminium is 2,712 kilograms per meter cubed. And we've been asked to work out the difference in mass between 5 meters cubed of tin and 5 meters cubed of aluminium. So we want to find the mass of 5 meters cubed of tin and 5 meters cubed of aluminium, and then we're going to work out the difference in that. Now obviously the 5 meters cubed in tin is going to be heavier because each meter cubed weighs 7,280 kilograms, whereas 1 meter cubed of aluminium only weighs 2,712 kilograms. Okay, so let's find the mass of the tin to begin with. So in terms of the tin, we know that each kilogram weighs 7,280 kilograms. We want the mass of 5 meters cubed, so we need to multiply this by 5. So we're going to do 7,280 multiplied by 5. And then that'll be the mass of 5 meters cubed of tin. And just think about it, that's the density times the volume. And the mass is equal to density times volume. So if we do this multiplication, 7,280 multiplied by 5. 5 times 0 is 0. 5 times 8 is 40, put the 0 down and carry a 4. 5 times 2 is 10, plus 4 is 14, put the 4 down and carry a 1. And 5 times 7 is 35, plus 1 is 36. So that means that the mass of 5 meters cubed of tin would be 36,400 kilograms. Now in terms of the aluminium, we're going to take the density of the aluminium, which is 2,712. This is the aluminium. And we're going to multiply that by the volume, which is 5, and that'll give us a total mass of 5 meters cubed of the aluminium. So 5 times 2 is 10, put the 0 down, carry a 1. 5 times 1 is 5, plus 1 is 6. 5 times 7 is 35, so put a 5 down and carry a 3. And 5 times 2 is 10, plus 3 is 13. So that means in terms of the aluminium, the mass of the 5 meters cubed of aluminium would be 13,560. Now, if we've been asked to work out the difference in mass, we want to find the difference in mass. So we're going to take the 36,400 and subtract 13,560 and see what we get. So 0 take away 0 is 0. 0 take away 6, we need to borrow here, so that's not a 3 and a 10. 10 take away 6 is 4. 3 take away 5, well, let's borrow again, that's not a 5 and a 13. 13 take away 5 is 8. 5 take away 3 is equal to 2, and 3 take away 1 is equal to 2. So the answer would be 22,840 kilograms. And that's it. So that's the difference in mass. Okay, let's look at our next question, question number 10. Okay, let's look at our next question, question number 10. So question number 10 says, Mr. Dixon is building a toy boat for his son, and he's got 3 different planks of wood to choose from, plank A, plank B, and plank C. And for plank A, we know its volume is 750 centimeters cubed, and its mass is 900 grams. For plank B, its volume is 0.0152 meters cubed, and its mass is 7.6 kilograms. And in terms of plank C, its volume is 1000 centimeters cubed, and its mass is 1.02 kilograms. And then we're told if wood has a density of under 1 gram per centimeter cubed, it will float. And the question is, which plank of wood is the most suitable? So obviously Mr. Dixon wants this boat to float, he doesn't want it to sink. So he wants to pick a plank of wood that has a density of under 1 gram per centimeter cubed. So let's work out the density of each of the planks. So let's start off with plank A. So plank A. To find the density, remember that density, we're just going to write that up here, density is equal to mass divided by volume. So if we take the mass and divide it by the volume, that'll be the density. So in terms of plank A, the density will be equal to the mass, which is 900 grams, divided by the volume, which is 750 centimeters cubed. And then if we take our calculator and work that out, 900 divided by 750 is equal to 1.2, so that's 1.2 grams per centimeter cubed. So that's going to sink because it's above 1 gram per centimeter cubed. So plank A will sink, so that's not a suitable choice. Plank B. So for plank B, we want to find its density, and the density is its mass divided by its volume. Now in terms of its mass and volume, because in the question we were told that it will float if the density is under 1 gram per centimeter cubed. So let's convert this volume and mass into centimeters cubed and grams. So in terms of the mass, well, that's 7.6 kilograms. The change from kilograms into grams we multiply by 1,000. So 7.6 times 1,000 would be 7,600 grams. So that's the mass of plank B. Let's find the volume. So we looked at this earlier on in the video. To change from meters cubed to centimeters cubed, you multiply by 1,000,000, because you multiply by 100 and by 100 and by 100 again, because each of the 3, the length, the width and the height are all, but whenever you convert them from meters to centimeters, you multiply by 100. So you're going to multiply by 100, 100 and 100 again. So if we take this 0.0152, you can multiply by 100, 100 and 100 again, or you can just multiply by 1,000,000 in one go, and that gives you an answer of 15,200 centimeters cubed. So that's the volume of that plank B. So the density would be its mass, which would be 7,600, divided by its volume, which is 15,200. And when we divide 7,600 by 15,200, we get an answer of 0.5. So that's 0.5 grams per centimeter cubed. So that one would float because it's under 1 gram per centimeter cubed, its density. So plank B would float, so that might be a suitable choice. And let's just double check and see if plank C floats or not. So its volume is in centimeters cubed, so that's great. The mass, however, is in kilograms, so we're going to multiply that by 1,000 to get it into grams, so that'll be 1,020 grams. So in terms of plank C, to get its density, we'll take the mass, which is 1,020, and divide it by its volume, which is 1,000. And when we do 1,020 divided by 1,000, that's 1.02 grams per centimeter cubed. So that's above 1 gram per centimeter cubed, so that one will sink. Plank C will sink. So that means the wood that he should use, Mr. Dixon should use, would be the wood from plank B. So which wood is the most suitable? Plank B. And that's it. Okay, so let's have a look at our next question, question number 11. So question number 11 says, the diagram below shows a solid block of ice. So we've got the solid block of ice, and it has got a side length of 81 centimeters. And we're told that the block of ice weighs half a ton. Now a ton weighs 1,000 kilograms, so half a ton would be 500 kilograms, so 500 kilograms, just gonna write that there. The block is a cube, so this is a cube with side length 81 centimeters. So that's 81 centimeters, that's 81 centimeters, and the height of it's 81 centimeters. And the question says, find the density of the ice and to give our answer in kilograms per cubic meter. So we want to give our answer in kilograms per cubic meter. So let's find the volume of this. Now we want to find the volume in cubic meter. So rather than doing 81 times 81 times 81 to get the volume of the cube in centimeters cubed, I'm actually going to write it in meters. So instead of 81 centimeters, I'm going to write 0.81 meters. 0.81 meters and 0.81 meters. So the volume of this block of ice would be, because it's a cube, the length times the width times the height, so it'd be 0.81 multiplied by 0.81 multiplied by 0.81, or 0.81 cubed. And the answer would be 0.81 cubed, or 0.81 times 0.81 times 0.81 would be 0.531441 meters cubed. So that's the volume of that block of ice. Now we want to find the density. So density is equal to the mass divided by the volume. So the mass is 500 divided by the volume, which is 0.531441. So if we just type this into our calculator and press equals, then that will give us the volume of the cube in kilograms per cubic meter, or kilograms per meter cubed. So let's type that in. 500 divided by answer is equal to 940.8382116 kilograms per meter cubed. And I'm going to run that to 2 decimal places, so that'll be 940.84, so 84 kilograms per meter cubed. And that's it. Okay, let's look at our next question, question number 12. Okay, so question number 12 says the diagram shows a solid cylinder. So this is a cylinder. We've got the diameter of the cylinder is 8 centimeters and the height of the cylinder is 15 centimeters. And the cylinder is made from titanium, so it's a solid titanium cylinder. And the density of the titanium is 4.43 grams per centimeter cubed. And we've been asked to work out the mass of the cylinder. So if we want to find the mass of the cylinder, the mass would be equal to the density multiplied by the volume. Because remember, the density is how heavy each centimeter cubed is, so 4.43 grams. And then if we just times it by the volume, that'll give us the mass of the whole cylinder. So we need to find the volume of the cylinder. So the volume of a cylinder is equal to pi r squared h. So you do the area of the circle, pi r squared, and then just multiply by how tall or how long the cylinder is. So we need to find the volume of this, so let's do that. So the volume would be pi multiplied by the radius. So the radius would be halfway across, that'd be 4. So you're going to do pi times 4 squared, and that would be the area of the circle. And then we're going to multiply by 15, so multiply by the height, 15. And let's do that, and it's a calculator question, so that's quite nice. So pi multiplied by 4 squared multiplied by 15 is equal to 240 pi, so 240 pi centimeters cubed, or as a decimal number, that would be equal to 753.9822369 centimeters cubed. So that's the volume of the cylinder. Now we've been asked to find the mass of the cylinder. Now each centimeter cubed has got a mass of 4.43 grams. So if we multiply this density, this 4.43, by the volume, 753.98 and so on, that'll be the mass of the cylinder. So let's do that. So 4.43 multiplied by 753.98 and so on is equal to 3,340.141309 grams. So that's the mass of the cylinder. And the question asks us to give it in grams. We've got here grams in the answer section. So it'll be 3,340 and it doesn't tell us to round it to so many decimal places. So I'm just going to round it to 2, so it's 0.14 to 2 decimal places. So that's the mass of the cylinder, 3,340.14 grams to 2 decimal places. Alternatively, if the question didn't specify it wanted it in grams, you could have written it as kilograms, that would have been 3.34 kilograms to 2 decimal places. Okay, let's take our next question, question number 13. Okay, so let's have a look at question number 13. So question number 13 says the diagram shows a solid triangular prism. So we've got this triangular prism, and the height of the triangular prism is 8 centimeters. The width of it is 6 centimeters, and the length of it is x centimeters. And then we're told the prism is made from wood and has a mass of 643.8 grams. And we're told the density of the wood is 1.85 grams per centimeter cubed. And the question says find the length of the prism. So if I was given this question here, where we've got the height is 8, the width is 6, and we want to find the length of the triangular prism, and we knew the volume, that'd be quite straightforward. But in this question, we don't know the volume yet, we just know the mass of the prism, and we know the density of the wood. So let's find the volume, because if we know the whole mass is 643.8 grams, and each centimetre cubed of wood has a mass of 1.85 grams, if we divide the mass by the density, that'll tell us how many centimeters cubed there are. In other words, the volume. So the volume is equal to the mass divided by the density. So let's work this out. So the mass is 643.8. The density, each centimeter cubed of wood has a mass of 1.85. If we divide the mass by the density, what do we get? That would be equal to 348 centimeters cubed. So the volume of this prism is 348 centimeters cubed. Now we want to find the length of it. So to find the volume of this prism, we would do half the base times the height to get the area of the front, and then we would multiply by how long it is. So in other words, the area of the front, let's find the area of the front. So half the base times the height, half of 6 multiplied by 8. And half of 6 is 3, times 8 is 24. So the area of the front is 24 centimeters squared. So 24 multiplied by the length, which is x, would be equal to 348. So if we divide 348 by 24, we'll find out what x is. So 348 divided by 24 is equal to 14.5, so 14.5. So that means that x is 14.5 centimeters. That's the length of the prism. So 14.5, and that's it. Okay, let's look at our next question, question number 14. Okay, so let's have a look at our next question, question number 14. So question number 14 says, material A has got a density of 5.8 grams per centimeter cubed. So every centimeter cubed of material A has got a mass of 5.8 grams. So that's its density. And material B, it's got a density of 4.1 grams per centimeter cubed. So every centimeter cubed of material B has got a mass of 4.1 grams. And then we're told that 377 grams of material A and 1.64 kilograms of material B for material C. And we've been asked to work out the density of material C. Now we know the mass of material C. If we add these two together, we'll get the mass of material C. So let's do that. Let's take the 1.64 kilograms, or that's 1,640 grams. So 1,640 grams, and then plus 377 grams. And if we add those together, that tells us the mass of material C. So 377 plus 1,640 is equal to 2,017 grams. So that's the mass of material C. Now we want to work out the density of material C. Now remember that density is equal to mass divided by volume. We know the mass of material C, we just need to find the volume of material C. So let's work out the volume of material C. Now to do that, what we need to do is we need to work out the volume of material A, we need to work out the volume of material B, and then add them together to get the volume of material C. So we're told that material A has got a density of 5.8 grams per centimeter cubed. And we know that for material A there's 377 grams. So if we divide the 377 by 5.8, that'll tell us how many centimeters cubed there will be. Because every single centimeter cubed has got a mass of 5.8 grams. So if we divide the total mass by 5.8, that'll tell us the volume. Or we could remember that volume is equal to mass divided by density. So for A, what we'll do is we'll take the mass, which is equal to 377. We'll divide that by its density, which is 5.8, and that'll tell us the volume. So 377 divided by 5.8 is equal to 65. So that'll be 65 centimeters cubed. So the volume of material A is 65 centimeters cubed. Now material B, so for material B, we know for material B, its mass is 1.64 kilograms. Now, because the density is 4.1 grams per centimeter cubed, I'm going to change this into grams, so it'll be 1,640 grams. And we're going to divide it by 4.1, because every single centimeter cubed has got a mass of 4.1 grams. So if we divide the total mass by 4.1, that'll tell us the volume. Or we could use the formula. So 1,640 divided by 4.1 is equal to 400. So we now know the volume of material A, which is 65 centimeters cubed. We know the volume of material B is 400 centimeters cubed. If we add them together, that'll be the volume of material C. So for material C, we'll do 400 plus 65 is equal to 465 centimeters cubed. So for material C, we now know its volume and we know its mass. Its mass is 2,017 grams. Its volume is 465 centimeters cubed. And if we divide the total mass by the volume, we'll find the density, the mass per centimeter cubed. So density is equal to the mass, which is 2,017, divided by the volume, which is 465, and that's equal to 4.33763 and so on centimeters cubed. And the question doesn't ask us to give it so many decimal places, so I'm going to give it the 2 decimal places, so that'll be 4.34 if we round up. So 4.34 grams per centimeter cubed. And that's it. So that's the density of material C to 2 decimal places. Okay, let's look at our next question, question number 15. Okay, so let's look at our next question, question number 15. So question number 15 says, liquid A and liquid B are mixed in the ratio of volumes 2 to 5 to make a liquid C. So liquid A and liquid B are mixed together to make a liquid C, and the ratio that they're mixed together in is 2 to 5. So in other words, 2 centimeters cubed of liquid A and 5 centimeters cubed of liquid B would mix together to form liquid C. And we're told that liquid A has got a density of 1.25 grams per centimeter cubed, and liquid B has got a density of 0.98 grams per centimeter cubed, and we've been asked to work out the density of liquid C. So we want to work out the density of this liquid C. So after these two liquids A and B have been mixed together in the ratio 2 to 5, what would that density of liquid C be? So what I'm going to do in this question is we could just consider a certain amount of liquid A and liquid B mixed together and then work out the density of then liquid C. And in terms of the quantities that we could choose, for instance, 2 centimeters cubed of liquid A and 5 centimeters cubed of liquid B. We could choose 200 centimeters cubed of liquid A and 500 centimeters cubed of liquid B, and so on. And it doesn't really matter because whenever you work out the density, you'll get the same answer. So I'm going to choose 2 centimeters cubed of liquid A, so 2 centimeters cubed of liquid A, and I'm going to choose 5 centimeters cubed of liquid B, and I'm going to mix them together to make liquid C, and they would make 7 centimeters cubed of liquid C. Okay, so let's have a look at this. So in terms of liquid A, we're using 2 centimeters cubed, so 2 centimeters cubed. And the density of liquid A is 1.25 grams per centimeter cubed. So every centimeter cubed has got a mass of 1.25 grams. And we're using 2 centimeters cubed. So if we double that, if we take the 1.25 and we multiply that by 2, that'll tell us the mass of liquid A. And 1.25 times 2 is equal to 2.5 grams. So 2 centimeters cubed of liquid A would have a mass of 2.5 grams. Okay, now in terms of liquid B, we're using 5 centimeters cubed of that. So let's find the mass of 5 centimeters cubed of liquid B. So each centimeter cubed of liquid B has a mass of 0.98 grams. So if we take that 0.98 and we multiply that by 5, that'll tell us the mass of liquid B, that 5 centimeters cubed of liquid B. So 0.98 multiplied by 5 is equal to 4.9. So that would have a mass, that liquid B would have a mass of 4.9 grams. So we've now got the mass of 2 centimeters cubed of liquid A, which is 2.5 grams. We've got the mass of 5 centimeters cubed of liquid B, which is 4.9 grams. And if we add them together, that'll be the mass of 7 centimeters cubed of liquid C. So 2.5 plus 4.9 is equal to 7.4 grams. So 7.4 grams. So we now know the mass of liquid C, we've got the volume of liquid C, then we can just divide to find the density of liquid C. So density is equal to the mass divided by the volume. The mass is 7.4 grams, the volume is 7 grams, and if we do 7.4 divided by 7, that'll be the density of liquid C. So 7.4 divided by 7 is equal to 1.05714 and so on grams per centimeter cubed. That would be the density of liquid C, 1.05714 and so on grams per centimeter cubed. And I've just put the units on for density there, grams per centimeter cubed. And in terms of this question, we weren't asked to round it to any particular number of decimal places, so we could just leave it like that. And in this question, I chose 2 centimeters cubed of liquid A and 5 centimeters cubed of liquid B. And you could have chosen different volumes. So for instance, you could have chosen 20 centimeters cubed and 50 centimeters cubed. And you could have done that question and you would have got the same answer, as long as the volumes that you chose are in the ratio 2 to 5. And that's it. Okay, let's have a look at our next question, question number 16. So question number 16 says, Winston's got 2 blocks, A and B, each made from a different metal. So they're made from different metals, and the density of the metal used to make block A is twice the density of the metal that's used to make block B. So this metal is more dense than this metal. Okay, then we're told the mass of block A is 6 times the mass of block B. So the mass of this block is 6 times the mass of that block. And then we've been asked to complete the sentence. The volume of block A is so many times the volume of block B. So we need to find this missing word. Okay, so in this question, we're dealing with volume. So let's write down the formula for volume. Volume is equal to the mass divided by the density. If you do the mass divided by the density, that'll give you the volume. Okay, so let's consider this. We were told the mass of block A is 6 times the mass of block B. So that would be 6 times bigger. The mass is 6 times bigger. But the density of the metal used for block A is twice the density of the metal used for block B. So that's twice as big. So if we were working out the volume of block B, you would do the mass of the block B and then divide it by the density of block B, and that give you the volume of block B. But if we're working out the volume of block A, we know the mass is 6 times bigger, and you know that the density is twice as big. So overall, that'll be 3 times bigger. So the volume of block A is 3 times the volume of block B, because 6 divided by 2 is equal to 3. So it's 3 times bigger. And you could just check that with some numbers. So for instance, you could if you look at block B, you could say for block B, the density of L in block B, let's make up some figures. So let's say that's equal to 2. And let's say that the mass of block B is equal to 50 grams. Then the volume of block B, so this is block B, and we've just made up some measurements there. We've said that the density is 2 grams per centimetre cubed, and we've got the mass of block B being 50 grams. So the volume of that block would be the mass, which is 50, divided by the density, which is 2, and 50 divided by 2 would be equal to 25. So the volume of block B would be 25 centimetres cubed. Okay, now let's consider block A. Well, for block A, you know that the density of the metal is twice the density of the metal used for block B. So let's double that. That'll be 4 grams per centimetre cubed. And in terms of the mass, you know that it's 6 times the mass of block B. So block B had a mass of 50 grams. We times that by 6, that'll be 300 grams. And then if you do, the volume is equal to the mass, which is 300, divided by the density, which is 4. 300 divided by 4, if you half and half it again, would be 75. So it's 75 centimetres cubed. So we've got the volume of block B and the volume of block A, and as you can see, it's 3 times bigger. So that's it. That's our answer. Okay, let's look at our next question, question number 17. Okay, let's have a look at our next question, question number 17. So question number 17 says, Isabella's loading granite tiles into her trailer that can carry up to 600 kilograms. And each tile measures 30 centimetres by 30 centimetres by 2.5 centimetres. And the density of the granite is 2.7 grams per centimetre cubed. And Isabella says that she can place 100 tiles into her trailer. And we're asked, is she correct? And to explain her answer. Okay, so what we're going to do is, I'm going to work out the mass of one of the tiles, because we know the dimension of each tile. It's 30 centimetres by 30 centimetres by 2.5 centimetres. So let's work out the volume. So 30 multiplied by 30 multiplied by 2.5, and let's see what we get. So 30 times 2.5 is equal to 2,250 centimetres cubed. So that's the volume of each of the tiles. Now, the density of the granite is 2.7 grams per centimetre cubed. So each centimetre cubed has got a mass of 2.7 grams. So if you multiply the volume by 2.7, we'll find the mass. Alternatively, you could learn that mass is equal to density times volume. So if you take the density, which is 2.7, and you multiply that by 2,250, that'll tell us the mass. So 2.7 multiplied by 2,250 is equal to 6,075 grams, or 6.075 kilograms, just changing that into kilograms by dividing by 1,000. So we now know the mass of one of the tiles, and she says that she can place 100 tiles into the trailer. So if we take the mass of one of them, 6.075, we multiply that by 100, that'll tell us the total mass of the tiles that Isabella's planning to put into the trailer. So whenever we multiply that, that's going to give us 607.5 kilograms. But the trailer can only hold up to 600 kilograms. So 607.5 kilograms is bigger than 600 kilograms. Now, she might risk it, but I probably wouldn't. But obviously, if she gets stopped by the police or something, she might get into trouble. So what we're going to do is, can she safely place them into the trailer? The answer is no, and let's explain that. And that's it. I've just explained that no, the 100 tiles weigh 607.5 kilograms, and the trailer can only carry 600 kilograms. And that's it. So Isabella's not correct. Okay, let's look at our next question, question number 18. Okay, so question number 18 is a calculator question. That's going to be quite handy for this question. And we're told the diagram shows a solid glass paperweight. So we've got this solid glass paperweight, and it's a hemisphere with a diameter of 6 centimetres. And the glass has got a density of 3 grams per centimetre cubed. And the question says, work out the mass of the paperweight. So we want to find the mass of this paperweight. So to find the mass of this paperweight, I'm going to first of all find the volume of the paperweight. So I want to find the volume of this hemisphere. So the volume of a sphere is equal to 4/3 pi r cubed. That's the volume of a sphere. So what we're going to do is we're going to work out the volume of the whole sphere, and then we're going to divide it by 2. Alternatively, you could divide this by 2, and that's equal to 2/3 pi r cubed. So you could just do 2/3 pi r cubed, and that'll give you the volume of the hemisphere. I tend to just work out the volume of the whole sphere and then half it. So I'm going to find the volume of the whole sphere. Now, r is the radius of the sphere, so that's from the center to the edge, so that'll be 3 centimeters. So r is equal to 3 centimeters. So the volume of the sphere is equal to 4/3 multiplied by pi multiplied by the radius, which is 3 cubed. So my calculator, I'm going to do 4/3. So I'm going to get my calculator. I'm going to press the fraction button, type in 4, then down 3, and then across, then multiply by, then pi multiplied by 3 cubed. And then whenever I press equals, that gives me an answer of 36 pi. So 36 pi, so 36 pi centimeters cubed. Alternatively, you may have it as a decimal, and as a decimal, that's 113.0973355 and so on centimeters cubed. So that's the volume of the whole sphere. Now, this isn't a whole sphere, this is a hemisphere, so now we need to divide by 2. So we're going to take our 36 pi, so 36 pi, and divide by 2, or our 113.097 and so on, and divide by 2. And whenever we divide by 2, that would be equal to 18 pi. Alternatively, if we're working as a decimal, divide by 2, that's equal to 56.5486677 and so on centimeters cubed. So that's the volume of the hemisphere. The volume of that hemisphere is 18 pi, or 56.5486677 and so on centimeters cubed. And it's okay to work exactly here. You could just say the volume is equal to 18 pi centimeters cubed. I'm just putting it as a decimal here because whenever I'm dealing with density, every single centimeter cubed has got a mass of 3 grams. So it just makes a bit more sense in terms of my, checking my answer makes sense if I have it like this, because I can see that we've got 56.54 and so on centimeters cubed. And when we times that by 3, I should get an answer of roughly about 170 grams. So we've now worked out the volume of the paperweight. We want to find the mass of the paperweight. So remember that with density, every single centimeter cubed has got a mass of 3 grams. So if we take the volume and times it by 3, that'll be the mass. Or you could learn that mass is equal to density times volume. So the density is 3. We're then going to times that by 56.548 and so on, or your 18 pi, and you get an answer of 54 pi, or 169.646 grams. And that's it. So that paperweight has got a mass of 169.646 grams. And that's it. Okay, let's have a look at our next question, question number 19. So question number 19 says, a solid metal sphere has got a radius of 4 centimeters correct to the nearest centimeter. So it's correct to the nearest centimeter. So that means that its lower bound, or the lowest possible radius, the lower bound would be 3.5 centimeters. And the upper bound would be 4.5 centimeters. So that would be the lower bound and upper bound for the radius of the sphere, because it's 4 centimeters to the nearest centimeter. And the mass of the sphere is 720 grams, correct 2 significant figures. So the mass has been rounded to 2 significant figures, and the answer is 720 grams. So the lower bound for the mass would be 715 grams, and the upper bound for the mass would be 725 grams. And if you need any extra help on that, finding the lower bounds and upper bounds, if you go to Corbettmaths and watch the videos on limits of accuracy, they'll be really useful for you. But if it's something's measured to 4 centimeters to the nearest centimeter, the lowest possible value, the lowest possible length it could be, would be 3.5 centimeters, and the upper bound would be 4.5 centimeters. And the question says, work out the greatest possible density of the metal and to give our answer to 3 significant figures. So we want to find density. So remember the density is equal to the mass divided by the volume. So if you do mass divided by volume, that's equal to density. Now we want the greatest possible density. So we want the biggest possible answer. So if we wanted the biggest possible answer, we would want this sphere to be as heavy as it could be in the smallest possible volume. So we want this sphere, if we want the greatest possible density, we want it to be as heavy as it can be in the smallest possible volume. And then if you do the biggest possible mass divided by the smallest possible volume, that'll give you the greatest density. Okay, so in terms of working this out, we know the greatest possible mass, so the upper bound for the mass would be 725 grams. So we're going to do 725 divided by the smallest possible volume. So in terms of the smallest possible volume, we know the radius of the sphere was 4 centimeters to the nearest centimeter. So we're going to use the lower bound for that. We're going to say, well, let's pretend it was only 3.5 centimeters. Let's go consider that lower bound. So the volume of a sphere, what we considered it earlier, is 4/3 pi r cubed. So that's 4/3 multiplied by pi multiplied by the radius. Now we're going to go for the lower bound, which is 3.5 cubed. And whenever we work that out on our calculator, we get an answer of 179.59438 centimeters cubed. So that's the lowest possible volume of that sphere. So that means we're going to divide, if we want the greatest possible density, we're going to do the heaviest possible mass divided by the smallest possible volume, and that'll give us the greatest possible density. So we're going to do 725 divided by 179.59438 and so on centimeters cubed. And whenever we do that, well, let's get our calculator and let's do 725 divided by answer. And whenever we do that, we get an answer of 4.03687465 and so on. So let's write that down. And that would be grams per centimeter cubed. Now the question is to give our answer to three significant figures. So let's round this to three significant figures. So that'll be 4.04. So 4.04 grams per centimeter cubed. And that's it. That's the greatest possible density of the metal to three significant figures. Okay, so let's have a look at our next question, question number 20. So question number 20 says the diagram shows a solid cone. So we've got the solid cone, and the cone's made from a material with a density of 5 grams per centimeter cubed. So every centimeter cubed of this material has got a mass of 5 grams. And the question is, write an expression for the mass of the cone in terms of x. As you can see here, the measurements are in terms of x. The diameter of the base of the cone is 6x, and the slant height is 5x. So we want to find the volume of the cone, and then once we find the volume of the cone, we can then find the expression for the mass of the cone. So let's find the volume of this cone. Now, in terms of the volume of a cone, the volume of a cone is equal to a third multiplied by pi multiplied by the radius squared times the height. So the radius r would be 3x. So the radius r, I'm just going to write radius, is equal to 3x. That's the radius, the halfway across the diameter, halfway across the base. And then in terms of the height's the perpendicular height, so that's the height going straight up. So here we've got a right angle triangle. That'll be a right angle triangle. We've got the radius is 3x. We've got the hypotenuse is 5x, and we want to find the height here, h. So let's use Pythagoras' theorem to find the height of this cone. So the height would be equal to, well, a squared plus b squared is equal to c squared. So a squared plus b squared is equal to c squared. A squared, that's going to be 3x squared, so 3x squared, plus b squared, that's going to be h squared, is equal to c squared, and that's going to be 5x squared. Now remember, we're squaring 3x, that's 3x times 3x, that's going to be 9x squared, plus h squared is equal to 5x times 5x is 25x squared. Now, if we take the 9x squared away from both sides, we'd get on this left-hand side just h squared. And on the right-hand side, we had 25x squared. We're taking away 9x squared. That'll leave us with 16x squared. So we've got h squared is equal to 16x squared. We want to find the height, so we're going to square root. So what multiplied by itself will give us 16x squared? That'll be 4x. So h is equal to 4x. So the height of this cone is 4x. So that means the volume of the cone would be equal to a third multiplied by pi multiplied by the radius of the base squared. So it's going to be, the radius of the base is 3x, so it's going to be 3x and then in brackets squared, multiplied by the perpendicular height, which is 4x. Now we just need to work this out. So that's going to be a third multiplied by pi. 3x times 3x is 9x squared, so times 9x squared times 4x. 9x squared times 4x, well 9 times 4 is 36, and x squared times x would be x cubed, so that would be a third multiplied by pi multiplied by 36x cubed. And a third of 36 is 12, so we'd get, if we simplify this, 12, and then we've got pi, and then we've got our x cubed. So the volume of this cone, the volume would be 12 pi x cubed centimeters cubed. The volume of the cone is 12 pi x cubed centimeters cubed. Now we want to find the mass of the cone. So remember that the density of the material is 5 grams per centimeter cubed. So every single centimeter cubed of this material has got a mass of 5 grams. So we just need to times this by 5 because of the mass is equal to the density multiplied by the volume. So if we take the volume, our 12 pi x cubed, and we multiply that by 5, that'll be equal to the mass. So 12 times 5 is 60, so that'll be 60 pi x cubed. And that's it, and that's in grams. And that's it, we found an expression for the mass of that cone. It'll be 60 pi x cubed, and that's it. And that's it. So these have been the video solutions to the Corbettmaths practice questions on density. And if you need any extra help on density, if you go to Corbettmaths and go to the videos and worksheet page and scroll down to video number 384, there's a dedicated video tutorial there on density. But I really hope you found this video useful. And if you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.